welcome back. In this video, we want to continue the topic of factorizing trinomial. In the previous video, we talked about it when the leading coefficient was 1, but here we want to talk about trinomials when the leading coefficient is not 1. This is the expression x squared plus m plus n multiplied by x plus m multiplied by n equals, it can factorize into two brackets. So each bracket contains the repeating term, which I just, for short, I write it as RT, and then another constant, which for short, I write it as NRT, non-repeating term. Then the other side would be the repeating term to the power 2 plus the sum of the two non-repeating term multiplied by the repeating term plus the product of the two non-repeating term. This is how you can look at a trinomial from a different perspective. This is the most general form of a trinomial that you can use. You can apply this identity to factorize it. So once more, if you have repeating term to the power 2 plus addition of two non-repeating terms multiplied by the repeating terms plus product of the two non-repeating terms together, you can factorize it into two brackets, which each bracket contains the repeating term plus one of the non-repeating terms. This is the general form. In the previous video, we talked about the most simple one, and we did a few practice questions when the A or the leading factor was 1. Here we talk about it when the A is not 1. Okay, here let's do an example. Here I have 4x squared plus 14x plus 12. This is a trinomial quadratic expression which has been written in order from the biggest power to the lowest power. It is called quadratic because the biggest power is 2, and it's trinomial because there are 3 terms, 1, 2, 3. So I'm trying to break it down into 2 brackets. I know the answer is already there, but let's ignore it and see how we can solve it. So the first step would be finding the perfect square term, okay? Because if you take a look at here, there is a term which is called the repeating term, and it's always raised to the power 2. So we have to look for a term which is a perfect square. And here, if you look closely, 4x squared is a perfect square. So I take this term, this is the repeating term to the power 2. I take the square root, which is 2x, then it gives me the repeating terms, right? Now, this term 14x is actually m. See, 14x is m plus n. See, m plus n, which is the non-repeating terms, multiplied by repeating terms. Okay, so 14x equals m plus n multiplied by 2x. Then what I do, I divide both sides by 2x, so m plus n would be 7. Okay, now on the other hand, there is another piece of information that I need in order to find the exact value for m and n. Here, I know that the product of the non-repeating terms together is 12. So the two non-repeating terms multiplied together is 12. I'm looking for two numbers multiplied together 12, added together 7, and if I pick it up, it's 4 and 3. Okay, so this expression is factorized into two brackets. If you take a look at it, these two brackets, compare them together, there is one repeating term in each one of these, and it's 2x, and the second term are non-repeating. Okay, so if I want to put an algorithm in order to, if I want to put all the steps in an algorithm, this is how you can do it. So if A is not equal to 1, so you have to look for the perfect square term, right? Then, like here, 4x squared was a perfect square. Then you take the square root of the perfect square term and it gives you the repeating term. Okay? Next step, you open two brackets. In each brackets, you write down the repeating term from this step and this step. Later on, you know that the multiplication of the non-repeating terms gives you the constant. And step 5, we have to find the non-repeating terms. In step 6, we substitute m and n in a step 3. So repeating term plus the two non-repeating terms. Okay, these are the steps. Maybe for the first few ones you can use this algorithm, but after more example you can just do it automatically. You don't have to just follow, all these steps. Like, you just do it automatically. Next example, 25x squared minus 10x minus 3. Maybe you can stop the video and try to do it on your own. Then you can check back your answer. Okay, first thing, you have to look for a term which is the perfect square. You are correct, 25x squared. Later on, we take the square root. The square root would be 5x. Then we add the two non-repeating terms, okay, multiply by the repeating terms. It must be equal to 10x. 10x coming from here. This step, we're trying to simplify both sides by 5x. So m plus n is equal to -2. On the other hand, the multiplication of the two non-repeating term, it's -3. So I'm looking for two numbers. If I add them, I get -2. Multiply them, I get -3, which are -3 and 1. And I substitute it back in here. This is the final answer. And the good thing here is, if you multiply or fold them back together, after simplification, you should get this side of the equal sign. Exactly the same thing. Okay, let's continue our video with the third example. 9x to the power 2 plus 6x minus 3. Please stop the video for a couple of minutes. Try to do it first and then check back your answer. All right, now let's do it together. The first step is to look for a term which is a perfect square. And the term here is, yes, you are correct, 9x squared. So 9x squared, we take the square root, 3x. This gives us the repeating term. So the repeating terms is 3x. Next, we know that the addition, if we add the two non-repeating terms multiplied by 3x, it should give us 6x, right? The 6x coming from here. Let's simplify both sides by dividing it by 3x. So m plus n gives us 2. So the sum of the two non-repeating terms must be 2. Another piece of information comes from the constant. We know that if we multiply the two constants together, we must get -3, right? So one of the non-repeating terms is 3, the other one is -1. And if we want to factorize it, there you go. Repeating terms plus non-repeating number 1, repeating terms plus non-repeating term number 2. Awesome job. Okay, next example, 121x squared plus 44x minus 5. This is another trinomial, and I want you to factorize it using the given identity which I introduced in the beginning of this video. And I want you to factorize it into two linear expressions. Okay, here the first step, as usual, we have to find a term which is perfect square. Yes, you're correct. 121x squared. We take the square root, it's 11x. Therefore, the repeating term is 11x. Next step, we have to look for the non-repeating terms, which are m and n. Okay, so m plus n multiplied by 11x, which is the repeating factor, and it must be equal to 44x, right? So here what we can do, we can divide both sides of the equation by 11x, which gives us m plus n equals 4. Then the other piece of information is m plus m multiplied by n must be equal to 5. So I'm looking for two numbers. Added together, I get 4, and multiplied together, I get negative 5. So these two numbers are 5 and negative 1. And this is the final answer. Repeating term plus 5 multiplied by repeating term minus 1. Awesome. You've got the final answer. Are you ready for the next one? Okay, this is another example. Okay, another example. Negative 2 over 7x minus 3 plus 1 over 49x squared. And I want you to factorize it again using the same identity which I introduced in the beginning of this video. Okay, yes, you are correct. First thing we have to do is to rearrange this expression from the biggest power to the lowest power. So this is what I do, from x to the power 2, x and the constant, right? After this, we have to look for a term which is a perfect square. I bet some of you might be confused at this point because so far the coefficient, the leading coefficient was a whole number like 4, 9, 16, 49. But we never came across like a leading coefficient which is a fraction. Is it a problem? No. The leading coefficient, or even in general, the coefficients can be anything. They are part of the real numbers. So basically, they can be fraction, positive, negative, decimals, anything. Okay? So here, I have to look for the, as I mentioned before, for the term which is a perfect square, and this is the one. Now I have to take the square root. I take the square root. Taking the square root gives me the repeating term. Later on, what I will do, I just add the two non-repeating terms multiplied by the repeating terms, and it should be equal to negative 2 over 7x, right? At this point, we have to simplify, right? What I can do, I can multiply both sides by 7 to get rid of the 7 in the denominator, right? To get m plus n multiplied by x equal negative 2x. So I can do another simplification, divide both sides by x, and get m plus n equal negative 2. The next piece of information comes from the constant. So I'm looking for two numbers multiplied together, getting negative 3. Okay. So the two numbers, the two constants I'm looking for, it's 1 and -3. So what I will do, I just substitute it back. 1/7 multiplied by x, which is a repeating factor. So some people prefer to write it like this, but some people prefer this form. Both of them are the same. It doesn't make any difference. So again, I have 1 and 3 as the non-repeating term. Now let's continue our video with another practice question. Uh, this is more challenging than the previous one. Here we will do 3x² plus 13x plus 14. And the question is asking us to use the same identity and to factorize it into two brackets. Okay, so again, we are looking for a term which is a perfect square. This is not, and this is not. So neither of these three are perfect square. Okay, so here we have to stop. If we don't have a term which is not a perfect square, that doesn't mean we have to stop and we cannot do anything. Well, actually, the good thing about math is you can manipulate. You can make some temporary adjustments so that after you make some changes, then it will be prepared or it would be in the format that you can apply the same rules. What I have to do now, I have to make one of this term to be the perfect square. So what I have to do, I have to multiply it by 3, right? I have to multiply it by 3 so that it becomes 9x², right? 9x² plus 39x plus 42. And then this one would be a perfect square. But hey, stop here, because right now what you did, you just multiplied your original expression by 3. So that means you tripled the original value. In order to return it back to its original value, later on, you can multiply it by 1/3 or divide it by 1/3. If you do so, it's like you are multiplying by 3 and dividing by 3, which these two will simplify together and it's equal to 1. And as you know, if we multiply an expression by 1, the value doesn't change, right? Because this is what you do. You multiply by 3 and then later on you divide the same expression by 3, so the whole thing wouldn't change. Okay? But what you did, you manipulate it so that now this one inside the green bracket can be factorized using the same identity. So here again, we open two brackets. We know that the repeating term, right, it's 9x². So we take the square root, it's 3x, right? And then we have to find the two non-repeating terms. So 39x is equal to addition of the two non-repeating terms multiplied by 3x. Let's simplify both sides by dividing by 3x. So 13 would be equal to m plus n. And then the other piece of information is we know that m multiplied by n, it must be equal to 42. So I'm looking for two constants or two terms which I multiply them, I get 42. I add them, I get 13. What are those? 6 and 7. So if you take a look at here, I substituted the green bracket with these two ones. And then I'm not done yet because remember, we have to multiply it by 1/3, or in other terms, we have to divide it by 3, right? So we can change it back to its original value. Here, what I will do is that I can factorize a 3 from the first bracket, right? Then I will cancel this 3 with this one. So the final answer after all the simplification would be x plus 2, 3x plus 7. Okay? And as you know, if you FOIL back these two together, you will get exactly this answer inside the pink brackets. You can give it a try and see if these two actually are equal together. Okay, let's continue with another example here. I have 7x squared plus 15x plus 2. And again, the question is using the same identity, factorize it into two brackets. Please stop the video, try to do it on your own, and check back your answer. All right. So here we have to look for a term which is the perfect square. Do we have such a term here? No. Well, if there is not such a term, we can make it. So I multiply it by 7. It will change into 49x squared plus 105x plus 14. But let's not forget that later on I have to divide it by 7 because I don't want to change the value, right? I just want to make a temporary change and then return it back to the original value. So now you can easily find the perfect square term. Take the square root. Okay, square root, it gives you 7x. This is your repeating term, right? Repeating term, you just open two brackets, repeating term, okay? And now this term in the middle, 105x, is equal to m plus n multiplied by the repeating term, 7x, right? So let's do some simplification. 7x, then 15 is equal to m plus n. On the other side, we know that on the other hand, we would know that 14 is equal to m multiplied by n. So if we're looking for two numbers, add them together, we get 15, multiply them together, we get 14. What are the two numbers? 14 and 1. So this is exactly equal to the green bracket. So this thing here, okay, let's not forget this thing here, okay, is exactly to this one, right? So we still have to divide everything by 1/7 so that we get back our original expression. Okay, so what we can do here, take a look at closely. In first bracket, you can factorize a 7, then you would have x plus 2. 7 with 7 would be simplified. Then your final answer would be x plus 2 multiplied by 7x plus 1. This is your final answer. In other words, this thing, it's if you multiply them back together would be equal to this thing, right? I hope you enjoyed this video. Please, let's do a recap together. In these videos, we were trying to factorize trinomials. Trinomials, that means three terms. And it was quadratic because the biggest power was 2. And then remember, we defined the coefficient of x squared to be the leading factor. So we started by saying that if the leading factor is 1 or not 1. If it was 1, that would be so easy. We just have to just find the two non-repeating terms which are equal to b. If they're added, multiply together, they equal to c. But if a is not equal to 1, then we come across two different situations. When the leading factor is a perfect square, or in other words, the term which have x squared is a perfect square, or when it is not a perfect square, and then you have to make some adjustments. All right. I hope you enjoyed this video. See you soon in another one.